Welcome to yet another exciting educational video brought to you by Chrysolite Tutors. So today we are looking at MTH 112 integration. We are defining indefinite integrals, basic rules, and techniques of integration. So by the end of this module, you should be able to understand integration as the reverse of differentiation, compute infinite integral using basic rules, apply the power rule for integration correctly, integrate sums, constants, multiples, polynomials, exponentials, and simple trig functions, handle integrals involving substitution, change of variables, apply integration techniques to simple algebraic and applied problems, interpret integration as a tool for area and accumulation. So sit tight and enjoy this video. It promises to be a good one. If you have to subscribe to our channel, kindly subscribe and share this video to others so that they can see what we are doing here. So integration, straight up, is the opposite of differentiation. Integration is the opposite of differentiation. So it's like we are going back. You understand? If you check out our videos on differentiation, you see that the answer we arrive at in differentiation, if you go your step backwards, you will get the question. So the integration means that where you are as a solution for differentiation, if you walk backwards to get the question, that is the integration. So if I have d dx of a function, and the answer is this, right? Therefore, integral f of x dx is equals to fx plus c, where c is the constant of integration, where c is the constant of integration. Okay, so why must we add c? Why must we add this c? Because any constant disappears when differentiating. You understand? So if there's any constant, disappears when differentiating. So if I was differentiating this one, for instance, now to get this one back, the constant will disappear. Okay. So let's take example. If, for instance, now we are to differentiate this, remember differentiation, d dx of this function, x squared plus 5. The answer for this is, I differentiate this x, this power 2 would multiply the coefficient 1, and this same power will reduce by 1. So the answer for this differentiation is 2x, right? But if I were to integrate it to get back this one, you understand? For integration, if I were to integrate 2x dx, this is what I'm integrating here. This is the sign for integration. If I'm integrating 2x, I'll be getting x squared plus c. This c, it can be any value, which is 5 here for this instance. We might not know what the c is, but we are putting it there to show that there's a constant there. And truly, where it came from, there's a constant which is 5. Okay, now we'll go into the power rule. Okay, so basic differentiation rules. These minor differentiation rules, but in reverse. Okay, so if I have for constants, in differentiation we have differentiation rules, right? Okay, so now for integration rules, number one, constant rule. So it shows that if I have, from integrating k dx, for instance, I must differentiate it, adding the variable. This is the x, the variable. So this constant is k. I'm adding this variable to it. Then I will now add constant c. Understand? That's for the constant rule. Then for the power rule, for cases or if n is not equals to 1, if n is not equals to 1, then I will have to integrate k f of x. What that means, k is the constant, then f of x is the function inside, right? Okay, dx is equals to k outside, f of x, sorry, k outside, sorry, k, right? Then f of x dx is equals to k integral f of x dx plus c. Okay, sorry for the mix-up. Let me take this power rule again. So if I have n is not equals to 1, right? So the integral of x n dx is equals to x raised to the power n plus 1 all over n plus 1 plus c. Okay, so what this power rule is saying is that if I have any variable raised by power, you understand? The standard integral for it is that I will add 1 to the power. At the same time, I will take the sum of that power and 1 and make it the denominator, then plus c. So this one is clear and straightforward. For instance, if I'm asked to integrate x raised to the power 5 dx, right? So this is the power. So from this standard integral, I will say x raised to the power 5 plus 1. At the same time, the denominator of this thing will now become 5 plus 1 plus c, right? So it is now x raised to the power 5, x to the power 6 over 6 plus c. So that will be the integral. Okay, so the power rule just states this. This is the power rule for if n is not equals to 1. This is the power rule. Okay. So the third one is the constant multiple rule. The constant multiple rule. Okay, for this rule, if I have integral k f of x dx, it's the same thing as saying k will come outside. This constant will come outside. It doesn't have to participate in the integral. It will come outside. And I will now integrate f of x dx. Right? So this is the constant multiple rule. Then the sum rule, finally, under the basic integration rules, the sum rule states that if I have integral of f of x plus g of x all dx, it's the same thing as integrating them term by term, because these are two terms inside one integral function. So it's the same thing as saying integral f of x dx plus integral g of x dx. So what this one is just saying is that I will integrate them one by one. So let's dive into some examples and apply all these things that we are just learning. Okay, so if I ask to integrate this, for example, see that there are 1, 2, 3, 4 terms in this expression. So we're going to be integrating it one by one. So it is the same thing as saying integral 5x raised to the power 4 dx minus integral 2x dx plus integral 7 dx. Okay, then plus a c, plus c, plus c. So I'm just splitting everything. Now this one is a constant term, can come outside. I can say 5 integral x raised to the power 4 dx minus, this one is also a constant term, 2 integral x dx plus integral 7 dx plus c. Okay, so I'm integrating this one now. 5 is outside. So 5 times, if you integrate x raised to the power 4, power rule, remember power rule, x raised to the power 4 plus 1 over 4 plus 1. The same power solution here is the same power solution here, right? Minus 2 outside. Then this one is the same thing as dot x. Power here is 1. 1 plus 1 over 1 plus 1, right? Plus, for constant, just say 7x. For constant, just add x to the 7. That's the x that you are differentiating it, integrating. Just add x to it. Then plus c. So I can resolve this. So this is 5x 4 plus 1 is 5. So the power here is 5 over 4 plus 4 is 5. So this is denominator of 5 minus 2, then x, right? 1 plus 1 is 2, all over 1 plus 1 is 2 downstairs here, plus 7c plus c. So 5 will cancel 5. I have 5 to the power x, sorry, x to the power 5, minus 2 will cancel 2. I have x to the power 2 plus 7x plus c. So this is the integral of this particular question. So it's easy enough. It's easy enough. Let's go to example 2. Okay, now I have this on the board, negative powers. So if we are to differentiate this, sorry, integrate this is a negative power. So what we will do is, again, add 1 to the power. The resultant also make it the denominator. So this is it. X raised to the power minus 3 plus 1 all over minus 3 plus 1. Whatever I have up here, I will replicate it down. Plus c, right? So x minus 3 plus 1 is minus 2. So I have x raised to the power minus 2 over minus 2 plus c. Okay, so at this point, I would bring this minus 2 out. That is minus 1 over 2 is x minus 2 plus c. Or I will say one whole number, oh sorry, not one whole number, minus 1 over 2x squared. Why? Because this minus 2 power will make this x become a denominator and the power becomes positive, right? Remember the law of indices. Law of indices. So this is it plus c. So this is how the answer looks like. Minus 1 over 2x squared plus c. Okay? So if I told to differentiate 1 over x, sorry, not differentiation, integration, 1 over x, integrate. So simply, once you have this thing, just do it like this, ln x plus c. So this is the standard integral for 1 over x, ln x plus c. That is for cases where n is not equals to 1. Where n is not equals to 1. Okay? So let's also go into integrating exponential and logarithm functions. Exponential and logarithmic functions. Okay. So for this one, if I have integral exponential x dx, it is same thing as exponential x plus c. And if I have exponential, and if I have a raised to the power x dx, the integral is a raised to the power x over ln a plus c. Please note these two. I've introduced two new standard integrals. In fact, these are the 3 new standard integrals. I have the 1 over x, that's inverse of x. The standard integral is ln x plus c. Then also exponential x dx, the standard integral is exponential x plus c. And a raised to the power x, standard integral is a raised to the power x over ln a plus c. So these are the standard integrals for this particular one. Okay, so we're going to apply it in examples. Okay, so if I have this particular one on the board, integrate, that's integral of 3 exponential 2x dx. Okay, so this one is a constant term, can come outside. I can write it like this, 3 integral exponential 2x dx. So to integrate this one, you just do, that's 3 outside. Yes, you just say exponential 2x over 2. This 2 here goes down. You understand? Then plus c. Plus c. Then if I plus c. Okay, plus c. So it is the same thing as saying 3 over 2 exponential 2x plus c. So that's the answer for this one. We're going to go into integrating basic trigonometric functions. I'll introduce you to some standard integrals of some trigonometric functions. So if you see integral sine x dx, the integral is minus cos x plus c. So it's just like as you have rules for differentiation. Now this is the rule for the integration. So anywhere you see sine x dx, you understand, is just the integral is minus cos x plus c. If you are told to integrate cos x ds, the integral is sine x plus c. If you are asked to integrate sec square x dx, this integral is tan x plus c. And if you are asked to integrate cosec square x dx, the standard integral is minus cot x plus c. And if I ask to integrate sec x tan x dx, the standard integral is sec x plus c. And if I ask to integrate cosec x cot x dx, the standard integral is minus cosec x plus c. Okay, so these are standard integrals. Wherever you see it in integration question, you just reproduce the corresponding answers. So we'll take examples where we apply this. Okay, so by way of application, we are looking at example 5, where we are told to integrate 3 cos x plus 4 sine x dx. So we can do them one by one. This 3 is a constant. It doesn't affect the differentiation integration, right? So this 3, I write it out. 3, then cos x integral is sine x, right? Then sine x is minus. So this, if I integrate sine x, I get minus cos x. So that minus already will affect this one. So minus 4 cos x plus c. So this one is just the answer straight up. Okay, so we have a situation where we have simple substitution. And this question on the board is like there's a composite. There's a composite. So this is like the reverse of a chain rule, where we will say let u be g function of x, right? And if we have integral f function f of gx dot g prime x dx is equals to f of u then du. That is, if you have the first function, if you differentiate the first function and get the second function, then you can apply this rule. Now, if I were to solve this one, for instance, we will say let u be 3x plus 2, right? Then du dx is equals to, that's if I differentiate u with respect to x is 3, right? Such that du is equals to 3 dx. That is if I make du subject to formula here now. So this one now, I can replace it with this one. That is, this rule can work. Why? Because this function here is the derivative of this function. So I can put this one inside here. That is, I have two components. This first component, u, is this, and du is this. So this can be expressed totally in terms of du. If I come here and say, anywhere I see any of these things, I put them. This is the question, right? So this is what I deduced. That if u is this and du dx is this, right? Or du is 3 dx, right? I can put these two equation. I can put them inside here. Okay, so integral. Where I see 3x plus 2, I put u, right? That's power 5. then dot. When I see 3dx, I put du. So invariably, I can just integrate this one, and I will have it as u to the power 5 plus 1 over 5 plus 1 plus c, right? Plus c. So u raised to the power 6 plus 6, sorry, over 6 plus c. Now, but our question is not in terms of u. It's in terms of x, right? So I'll come back again and put what x is there. So I'll have it as 3x plus 2 over, sorry, raised to the power 6 over 6 plus c. So this is the integral of that particular question. Okay, so on our question on the board, it says integrate x square root s squared plus 1 dx. So again, this is like a composite, and I'm going to say let u be equals to x squared plus 1, right? Make sure that your u is always the simplest function. This is the function inside this function. And du dx is 2x, right? I can still rewrite this one in the linear form. Du is equals to 2x dx. That is, I just multiply this by this now to make the use of the formula. You understand? Now I'm going to express this in terms of u and du. So I can integrate the u. Watch this. I'm looking at this and I'm looking at this. How can I put these two expressions inside here so that only u will be showing, nothing like x, right? Okay, now, if you watch this closely, u can take this one, right? Can take this one here. But I have x outside, I have the x here. So I can express this x dx in terms of du and 2, right? I can say x dx, that's from here. Okay, du over 2 is equals to x dx. I am seeing x dx here. If I rearrange this, look at it, if I arrange this, this is integral square root x squared plus 1 dot x dx. That is, this x came here so that it can be like this, you understand? So now I have gotten how to substitute this. Let me go and substitute here now. So this now becomes integral. Instead of having x squared plus 1, I'll be having u. That's square root of u dot. Instead of having x dx, I'll be having du over 2. du over 2. So you see that I've just expressed the whole of this in terms of only u and du. You know this one is a constant. I can bring it out. That is half. Then integral of this one, I can say u raised to the power half again, then dot du. So here I have resolved this to this. I can just integrate this one simply. So this one now is half outside, then u half plus 1 over half plus 1 plus c. Okay, plus c here, sorry, leave this one like this. Okay, so this is half u raised to the power 3 over 2 over 3 over 2. So this one too can also be resolved. It can also be resolved to, this can cancel this. Because this one is simply as saying half divided by 3 over 2 times 2 over 3, right? So I have 1 over 3. So this and this will give me 1 over 3, right? 1 over 3, 1 over 3, because this divided by this is 1 over 3, right? Dot u raised to the power 3 over 2 plus c. But we don't have u in the initial question. What is u? What is u? U is this one, right? Substitute it inside here. So I have 1 over 3, open big bracket, I put x squared plus 1, close the bracket, 3 over 2 as power, then plus c. So that is the final answer for that. So if we are integrating rational functions, okay, what does that mean? That's in simple forms, just simple forms, okay? What does that mean? if I have, okay, case 1, if I have integral 1 over ax plus b dx, understand, it resolves into 1 over a ln ax plus b plus c. Remember I said that 1 over x, the integral is ln x plus c, right? So we are using that in this same form, but just that this coefficient before the x is brought out as 1 over a, but still ln whatever we have as denominator, then plus c. So this is a standard integral for this particular case. So if we have an example like this, example, integral 1 over 2x minus 3 dx. So it now becomes, remember I said this coefficient of x comes outside, you understand, as 1 over 2 ln then 2x minus 3 plus c. So this one is simple enough. Then for another case, if I have another example, is 1, then number 2. If I have integral x over x squared plus 1, then dx. Now this one, I will say let me do it in a fresh page. So I want to integrate this. For instance, I will say let u be x squared plus 1. Therefore, du dx is 2x and du is 2x dx, right? That's if I cross multiply. Okay, now how do I make this one like that? How do I make it like that? The first thing I will do is I know that x dx is here, x dx is here. I'll write this one again. See? Integral 1 over x squared plus 1, right? Then dot x dx. This is just rewriting this, right? And this one now looks in this form. I have this this one here, and this one at denominator. So, but you know this one now that I have here, I have 2 by the side, so I can resolve this again. Let me remove this. I can change this one to du over 2 is equals to x dx. So this is what, when I see x dx, I put du over 2, right? So I write this one again, I say integral 1 over, so wherever I see x squared plus 1, I put u, right? Then this one is the same thing as du over 2, okay? Du over 2. So this one is the same thing as 1 over 2 outside. These 2 will come out, 1 over 2 outside. Then ln u plus c. But u is giving us something, right? We know u as something. So u is 1 over 2. Ln u is x squared plus 1, then plus c. So that's the final answer. So I will put some questions in the comment section. Your TMA question 2 are also solved. If you need a solution, you can contact us directly. I hope this video has been informative for you. I'd like to thank you for viewing.